Okay, we continue. So here we finish with this one, and you know that you can calculate with the Excel. I'm sure Dr. Farzana teach you how to use the Excel. What about the time that we have dependent sample? For example, imagine now you want to buy a car. You will go to different shop and you compare the price of the same car from different shop. Or you want to buy a house, for example, it's the same house. You are going to different agent and you just check the price. So this is the time that is the sample is dependent, right? So how to calculate for that one? You see, when you want to go and buy any kind of product, you compare the price. You see that, okay, this shop, for example, selling 10 ringgit, the next shop selling 9 ringgit. So normally you get the differences, right? Exactly same thing happening here. Normally we get the differences. You see, this is T, but this T is differences. We have to be careful. Normally we do this mistake that we mix this T with the previous T. So here, with this dependent sample, imagine you go to the gym to lose weight. You compare before and after, right? So this is the differences before and after. You come to the business statistic class. You compare your knowledge before and after. So we use this formula. We get the D, that is differences, but we get the mean of the differences. We get the standard deviation of the differences, and we have N, so we can calculate it. Look at it here. We have here they give us example of the selling house between two agents. So it's the same house that two agents trying to sell the same house. Now they give us a sample of 10 agents that they are selling the same house, and they ask us to see with a significant level of 0.05, can we conclude that there is a differences in the mean appraised value of the home? So what to do now? Of course, we have to go to the process of writing the hypothesis, but we know which test we have to use, right? Because they said the differences. Is there any differences between the two different agents selling the same house? So we write the null and alternative hypothesis. The null going to be there is no differences. It means that the differences is 0. And the alternative hypothesis is going to be there is differences. The differences is not 0. So level of significance, they will give it to us. Which test we have to use? The differences, that is T, of course. How to get the value from the T? You already know how to go to the table, T table, and calculate the degree of freedom. Look at the degree of freedom here. Is n minus 1. You know what is the reason? Because they are dependent sample. Is not different independent sample. Is dependent. So when it's dependent, we just count it as a 1, right? So the significant level going to be divided by 2. So we have 10 sample that they are independent. So we just consider 10 minus 1. And we consider, of course, how to get from the table, you know already. So we have to calculate the differences, right? It's because we have two agents. It's like buying 10 ringgit and 9 ringgit. So here we calculate, you see here, we calculate the differences, from each other. And after that, square it. So you will get the differences. You will calculate the mean first. After that, you calculate the standard deviation and put everything in the formula and get the differences. So after that, next step, you have to decide. Now you have to compare the value that you get from the table and the value that you get from the formula. Exactly the same thing happened. So when you compare, now you have to decide the value that you get from the formula is in the rejection area or is in the acceptance area. So because here is 3.3 is greater than the critical value that we have, it means that in the rejection area, we reject the null hypothesis. What does it mean? The data indicate that there is a significant statistical differences. We reject the null. So it means that we accept the alternative hypothesis. It means that there is a differences, right? So again, you can calculate with the Excel. So which one is better? Dependent sample is better or independent sample? We can say that dependent sample is better because the variation is less. You see, it's the same house selling by two companies, so the variation is less. So maybe we can say that dependent sample is of course better. Talking about the population proportion, that normally end of each chapter we talk about it. Some of this already discussed in the previous chapter, but we just explain it again. So we said for proportion, it means that it's a proportion of the population. And don't forget that few rule that we have, that the 4 conditions that we apply for binomial distribution is always apply for the proportion, and the mean and variance always should be greater than 5 if we want to use all this Z formula. So this already solved in chapter 10, I think, but we solve it again. So imagine that suppose prior election in a certain state indicate that it's necessary for the candidate for governor to receive at least 80% of the vote to re-elect. So the government is interested in assessing his chance of returning to the office and plan to conduct a survey of 2,000 registered voters. Using the hypothesis testing procedure, assess the government chance of re-election. So we go through the writing the exactly 6 steps of hypothesis. First, we have to write the null and alternative hypothesis. Don't forget that you will search for the keyword. Here, the keyword is at least. So you see the keyword is going to be an alternative hypothesis. That is should be greater than 80 if you want to come back to the office. At least should be 80, right? So significant level, they give it to us already. After that, we will calculate the mean and variance. It should be greater than 5 to see if we can use the Z-test, of course. So if possible, we use it. And we have a formula that we have a sample proportion, we have population proportion, and we have N. So let's see from the information that we have. Of course, this example, you should check your book because half of the example is not here. They said if 1,550 of them vote for this candidate. That is not in this slide, so check your book. So from that 1,550 that vote for this candidate, that we can get the sample proportion, and we have population proportion that they said 80% of them they will vote normally. So we have both. We have population proportion, we have sample proportion, and now of course we have N, that is 2,000. We can calculate. So exactly the same thing happening here as previously explained. We decide which area is rejection area, which area is acceptance area. Now the value that we get, of course, because we said at least, right? So in the negative side, and we compare the value from the formula with the significant level, that is minus 1.6. So the value that we get from the formula is greater than, it's in the negative side, right? The value that we get from the table. So we conclude that, okay, it's located in the rejection area, so we have to reject the null hypothesis. And interpret result is the differences of 2.5 percentage point between the sample proportion and hypothesis is significant, so we reject the null hypothesis. And so what about 2 sample tests for proportion that we discussed in this chapter 11? So you see the Vice President of Human Resource wished to know whether there is a differences in the proportion of hourly employee who miss more than 5 days of work per year at 2 different companies. So you see they have 2 sample and 2 population. So what to do with this kind of example? Don't forget that what we did in the t-test, and we pull them together, and after that we solve the question. Exactly, we are doing the same thing here. We have 2 samples, so we pull them together, and after that we can use the Z formula to solve it. Look at it here. We have first sample proportion, second sample proportion. We pull them together. Here you can see that we pull them together and we use the formula to solve it. Okay. So here show how to pull two samples together, of course. And this is another example. So there is a company, perfume company, that they want to know, is there any differences between the proportion of the younger and older women that they prefer to purchase a specific perfume. So they do the survey, and after that they decide based on the result. Now they said check if there is a differences between these two. So you go through the sixth stage of hypothesis testing. Write the null and alternative hypothesis, that is there any differences between these two or not. So is again difference and no difference. So you have to write the null and alternative based on that. Significant level, they already give it to us. For the population proportion is always Z distribution. We already know that. And we have to write the decision rule, that when we are going to reject and when we are going to accept, where is the rejection area and where is the acceptance area. So based on the value from the table, we can decide where is the rejection and where is the acceptance area. So significant level, they already give it to us. We divide it by 2, so it's 2 tail of the curve, and the value is 1.96. Now we have to get the value from formula to be able to compare them together. So look at it here. We have the value, of course, for both sample. So we calculate the sample proportion for each one. After that, pull them together. So when merge them together, pull them together, now we can put in the final formula and get the value of minus 2.2. Now we have the value from the formula, we have the value from the table, we compare them together and see that the value from formula is in the rejection area or is in the acceptance area. This minus 2.2 is greater than 1.9, right? So it means that in the rejection area. So it means that we have to reject our null hypothesis and accept our alternative hypothesis.